Thank you for joining. Let's start evening session, afternoon session. First speaker is Masanori Ito. He's talking about the AGL and 5G multi-slice network data communication in SDV era. So, please, Ito-san.
Yeah, thank you very much, Yamaguchi-san, for introduction. I'm Masanori Ito from Toyota Motor Corporation. And before beginning my presentation, so this QR code, so right now at the AGL, so automotive grade Linux community, we are conducting a survey to find out the factors preventing upstream contribution especially in the automotive industry. And this is a survey, and Jerry kindly helped us to translate the original English and Japanese survey, and do please participate. Okay, thank you very much. And at first, please allow me introducing myself a little bit. So I'm Masanori Ito from Toyota Motor Corporation, and at work, so I'm a kind of double hat guy, and one is R&D side, and the other is so how many of you know what is OSPO, Open Source Program Office? No, okay, yeah. Anyway, so this is a one-stop organization within a company to promote the open source utilization or consumption and also contribution, both sides. Management side and also the community activity side. Okay, and my talk is mainly from the technical side. But at the last and also, the survey. So this survey is from the management, so OSPO side. Okay, and this is today. So the agenda of my work today. And at first, so I'd like to walk through the overview of the contemporary vehicle IT systems. Okay, and also the next I will walk through what is AGL. Okay, and then the third point, so I will explain a little bit deep dive into the 5G cellular network, and also the integration of the AGL and also 5G network, open source software things, and finally, so I will share some POC at AECC. AECC stands for Automotive Edge Computing Consortium. Sorry, by the way, so this QR code. So this QR code is my presentation. Just a moment. So I have already uploaded publicly. My presentation. So accessible from the internet. And just a moment. So again, QR code is this one. Okay. So please download if you like. Okay. Okay. Yeah. Okay. Then let's get started. At first, overview of the so-called connected vehicle data processing. And right now, at the moment, there is a kind of trend, so-called SDV, software-defined vehicle. And I think Jerry and also Kurokawa-san, one of the other guys are working on the AGL, made presentations regarding the SDV. But before SDV, in our industry, automotive industry, there is a trend, so-called CASE. CASE stands for connected, autonomous, and shared or service, and also electric, EV, battery EV. Okay, and under this trend, vehicles send out huge amount of data, and also the structure of the data is very complex. So that's why in the automotive industry, so we have to work on not just vehicle side, but the data center side, and also, as you can see here, mobile, so wireless network portion, and also backbone network portion too. Okay, and So in today's my talk, so regarding the network things, so I would focus. So I'll be focusing on the cellular network mainly. Okay. Yeah. So simply speaking, 5G network like our smartphone. Okay. and by and yeah and by the way, so in order to show how complex a vehicle is, right? So nowadays, so I have a question. So how many CPUs in the vehicle do you think nowadays? Then what about 5? No, okay, 10. Okay, the 50. Okay, the 100. Yes, okay. Then more than 100. For example, 150 or 200. No, and more, 1,000. Yeah, but actually, so nowadays, even so low-end vehicle has at least 100, and luxury vehicles has. So it depends on, but still, so from 150 to 200, and sorry, so this is so Japanese presentation, but I think Chinese folks can be this country, okay, and this portion shows the logical diagram of the so processor network inside a vehicle, okay. And also, this is a harness, yeah, wire cables. And it's, so as you can see here, the bundle is like this. So simply speaking, huge amount of processors and also cables. So this is a reality. So just I wanted to show so how complex it is in a vehicle. Okay. Sorry. And also, yeah, on top of these, so next topic is AGL and also SDV architecture. And so here the point is among, so right now, although I said so more than 100 processors, but it varies, the size varies from the very small embedded controller ones to the bigger ones, like the one with GPU capability also, okay. And also, yeah, here, so AGL, so we have AGL, okay. So nowadays, so including our vehicle, Toyota vehicle, and also other OEM, some vehicle manufacturers' vehicles are normally running Linux for this kind of. So I think you, most of you guys drive the car, and so beside the handle there is a LCD panel, so touch panel like this, okay, and of course behind these touch panel or the speed meters, so behind them there are some CPUs with a bit rich CPUs, okay, like general purpose ones, and on top of those processors nowadays, considerable amount of embedded Linux are running, and in case of, and most of them are based on Yocto Linux, and this. So I think Jerry or Kuruka-san explained what is Yocto. Yeah. And anyway, so simply speaking, Yocto Linux is a framework for embedded Linux development, and so AGL is built on top of this one like this. Okay. Yeah. Okay. And next one is our automotive AGL reference architecture for the SDV, and the code name is SODEV. And the reason why I show this again is actually at Toyota, I'm working roughly less than 10 years, but my professional career is roughly 30 years. Okay, and I'm from outside vehicle world, and before joining Toyota, I worked on the data center infrastructure things like cloud operating system, and so that's why I'm familiar with operating system layer and also hypervisor layer, and here is some room to work on from my side too. Okay. And so that's why, and regarding the AGL community activity, since last year, it's just last year, I began to work on. But still, I think I'm collaborating with AGL folks. Well, I believe so. Okay, yeah. And next topic is 5G. Sorry, changing the topic very quickly, but anyway, so from this slide, I will talking about not vehicles, but smartphone or cellular network. Okay. And simply speaking, nowadays the mobile network operator system can be divided into the upper side, controller side, and also the data plane side. But in the telecom industry, normally they say U plane, not D plane. As I'm from IT, so IT side, so I feel so I'm still feeling calling D plane as U plane is strange. But anyway, so this is the way how they call it. So how they call it. Okay, and so here a bunch of the something functions, and here is the explanation. But I will not. So today in my talk, I will not dive into these C plane things. So I will mention only user plane things. Only today, okay? Yeah, okay. And here, so I think lots of mobile network operators are appealing the benefit of 5G network like this. So in case of 5G, you can send out a bunch of data. So in other words, so huge bandwidth and also very low latency. So these are what they are talking about normally, I think. But actually, so there are at least one more feature of 5G mobile cellular network. So it's so-called slice. Okay, slice is so if you guys are familiar with the data center network like Ethernet, so slice can be regarded as as VLAN, virtual LAN. Okay, and slice by slice, so mobile network operator can provide communication specific benefits. Okay, in this example, so slice 1 is number 1. Okay, and the other one, slice 2 is bandwidth optimized one. And by using these slices, for example, of course, so bunch of millions of IoT devices can connect to the internet through the normal slice. But so I think watching a movie, for example, watching a movie requires bandwidth requirement. Yeah, okay. So at home, and this and this requires heavy traffic, cellular network traffic. And in case of vehicles, okay, sometimes we want to upload or download the video data taken by the onboard video camera, and okay. But normally, so in order to communicate with the data center side, controlling the connected vehicles, so it's okay just using the normal slice. And here the point is from the mobile network operator side, slice 2 has higher benefit, and that means expensive. Okay, so that's why from our side, OEM side, so vehicle manufacturer side, so it's important to do some kind of adaptive switching between the these multiple slices. So I think so we can say this one bandwidth optimized one, so premier service. Okay. ちょっと喋りすぎてるかもしれません。Okay. And so far, so I walked through the benefit, hidden benefit of the 5G mobile network. Okay. And from here, so I will talk about the integration of the 5G mobile network stack built by open source things, and also AGL. Okay. And here and right now, so far as I know, so there are 3 kinds of open source implementation of 5G mobile network. One is free 5GC, and the second one is open 5GS, and the last one is open AI interface, so-called OAI. Okay. And this UE Ransim is and as these things are focusing on the C plane side only, normally. So that's why there is one more implementation, so-called UE run scheme, and this component implements. So simply speaking, like smartphone. Okay. Yeah, and also the last one, Nefio is a kind of network function orchestrator on top of Kubernetes. But this, so in this talk, this is outside the scope of my talk. So by the way, so Free5GC, this is a work of Taiwan University. Yeah, great work, I think. Yeah. Yeah, and also they joined to the Linux Foundation, and so I'd like to collaborate with. So I'd like to contribute to Free5GC component from us too. Yeah. Okay. Oh, sorry. Yeah, and from this slide, so I'd like to share some some a bit technical things with respect to the integration of AGL and 5G open source network stack. So here I mean Free5GC and UE regime, as I stated here. Okay. Yeah, and here the first point. So from a viewpoint of AGL is how we can integrate the UE user equipment, I mean the 5G terminal. And in order to do this, we need to write so-called Yocto recipe, okay? And and actually there, so already there is, and actually so I did it, okay? Yeah, and the usage is very simple, and so if you want to try this one, so you can read the README, and so I believe easily reproduce this result, I think. Okay. And the next one, sorry, I spent a little bit more time than I expected, so I'd like to skip some things, but skip this thing, but so from my standpoint, so I'm working on not only the 5G cellular network connectivity, but also the observability of the end-to-end system. So here I mean the system starting from the vehicle side and through the mobile network and backbone network and also cloud data center side. Okay, and yeah, and in order to do this, so I wanted to enable to use the so-called EBPF feature of Linux operating system. In the EBPF world, there is a feature so-called core compile once run everywhere feature, and this requires some additional configuration of the Yocto Linux kernel, and you can do this, and you can do this by following this simple additional configuration when you build Yocto Linux, like AGL. Okay, and also and also in terms of observability, so I also working on the open telemetry collector, so-called OTEL core. Okay, this is under development, and actually there is a bit tricky issue where during the build process of the OTEL core, okay, OTEL core tries to convert some data by using the process, the intermediate process program generated by the build process of OTEL core itself. And here, I think if there, here are some folks familiar with embedded things. Normally we do cross compile. For example, build the target system on top of x86, and the target is ARM 68 or 68 or so. Yeah, okay. And here the problem is the generated process program is ARM architecture, but the cross-build system tries to run it on top of the Intel-based ones. So that's why open telemetry collector, OTEL core build system needs some more additional consideration regarding the cross compiler, like this one. Yeah, okay. And yeah, and this is the schema. So regarding the AGL and also 5G network stack, and also additionally, so observability stack integration. And if we integrate the 5G stack into AGL, as I explained, and also when we want to use more than 2 slices from the one Linux operating system like this. So green box is one AGL operating system instance. Okay, and we can, and by using UE Ransim, NRUE is a part of UE Ransim distribution, and the control process to create this kind of tunnels, so to the emulated 5G network. Okay, and we can create so one tunnel per one slice manner. And in this case, so as I wanted to create 2 slices and connect them to a single AGL instances. So that's why right now there are two tunnels. Okay. And one more topic is when, so as I mentioned in this diagram, so what we want to do is so a kind of adaptive switching between multiple, 2 slices. Okay, and in order to do so, for example, when we want to upload large data to, for example, Amazon S3 service, we want to use bandwidth optimized slice. And in order to do so, depending on the target, we have to change the exit exit tunnel. Okay, am I clear? Okay, yeah. And in case of Android or iPhone, so they already have, but that kind of mechanism, so-called URSP. So I right now, sorry, I can't remember what URSP stands for, but user resource switching something. Sorry, but in case of generic Linux like AGL, so there are no standardized mechanisms like URSP. So implementing URSP or other techniques. So in this sense, so there are some workaround. And in case of me, I wrote a small program. So looking at the destination network and also switch the target tunnel to be used. Okay. Yeah, this is a very early stage stupid workaround, but still so in my POC, so this worked. Okay. Yeah, thank you. ちょっと23分。まだ大丈夫。Okay. Yeah, okay. So these are what I did. So I did in my POC technically. Okay, and the last portion is, so I would like to share the inter-community collaboration. Okay, okay, and there is an collaborative organization, so-called AECC, as I mentioned. And under this, and under this organization, right now, so they publish lots of white papers and also a technical report of POCs that they carried out. And among this one, right now they have roughly 15 reports of POCs, and among these ones, so right now, I'm a little bit in collaboration with the team that carried the POC number 10, so optimal edge selection for realizing digital twins and green energy utilization. And right now, what they did is from the vehicle side. So they wrote just a vehicle data generator and run it on top of some general Unix such as Ubuntu or so. And here, my point is, it's just generating the data traffic only. But so here my point is it's better to do the POC by using the actual, so if possible, actual vehicle. But it's difficult because so one vehicle is very expensive. So that's why. So instead of using so physical vehicles, my idea, so our idea is use the AG, so use the open source based operating system like AGL, and also run them on top of virtual machines. And by doing so, we can have bunch of virtual vehicles on top of cloud infrastructure. Yeah, whichever of the on-premise private cloud or AWS you like. Yeah. Yeah. Okay. And So this is a and this is the basic idea. And one more point is, so far this team doesn't use the this team uses only one slice. So that's why. So my next idea, next point of my idea is so extend their configuration to multiple slices and do this kind of so here is slice 1 and slice 2 and terminating the edge environment and connecting to the data center. So by carrying out this kind of extension, technical extension, so I thought so I can extend the result and the value of their POC. Okay. So simply speaking, so this is what I'm doing. Okay. So何分喋ってる? Yeah, okay, sorry. So I'm running out of my time. And so in my slide, so as you can see, so I explained the actual configuration of the free 5GC, so mainly free 5GC side, and also tips to build the mobile network side, MNO side things. Okay. So actually there are some tips, especially when we want to use multiple slices from a single operating system like this. So a bit tricky, but still, so it works if you follow procedure like this. So these are my points. Okay. So eventually, so in addition to so integrate so AGL and free 5GC stack, so I want to integrate some more things. So outside that ACC activities, so as a part of my R&D works, so right now, so I'm working on something like VVF stands for Virtual Vehicle Fleet Manager. Okay. So simply speaking, so to have central control point of the bunch of virtual vehicles. Okay. Like this. Okay. And this is what I'm doing at Toyota, and also collaborating with folks outside Toyota, so at ACC. Okay. And in summary, what I walked through today is the AGL and its SDV reference platform. So here, so full OSS is one point, and also second, so I walked through the 5G cellular network with multi-slice features, and it's full open source stack. And here again, so we can do this. So only using full OSS, so fully OSS components, and also POC based on AGL and also AGL and also open source 5G cellular network stack with cross community collaboration. Thank you. So basically, so that's all I have today. And so in my slides, so I added my previous talks. I made some previous talks like this, and so if you have time, so I'm very happy. And also the last one is the OSPG survey that so at first I mentioned. Okay, and actually, so this is not my R&D work, but the management side work, and last month we began to conduct this survey, and so far we have got 58 responses from 33 Japanese responses and 25 English responses, and so far we haven't carried out the deep analysis. But first, looking at my first impression is maybe Japan. So I'm from Japan. Okay, Japan could be the worst place to work on open source contribution. But anyway, but of course this is just a first impression. Okay, and there are some opinions like these ones. So and so that's why. So I want to hear more responses from Taiwan or China. So anyways, outside Japan or or outside OEM, vehicle manufacturers. Yeah, this is my point. And sorry, and again, so this one is the Chinese version survey. So call for participation. So that's one. So that's what I wanted to share. Thank you very much. Any questions?
Thank you, Ito-san. So, this survey just created by Jerry. Yeah.
So he's one. So he's a great one.
Have a question? Yes.
Thank you for your presentation. This is very cool. And my question is about the what's your points about the V2X? I know that now in the 5G there is a mechanism called CV2X. So I just wondering, do you have any thoughts about this one?
Sorry, could you speak up more? So your question is about
V2X. V2X.
V2X. Okay. Very good point.
So I want to know your thoughts about V2X and how it can be applied to the real world. Thank you.
Thank you very much for your question. And V2X stands for vehicle to simply speaking everything. Okay, and in this sense, so the target of the communication varies, and vehicle to vehicle or vehicle. And even within the vehicle to vehicle, there are several network possible connections, like cellular network that I mentioned today, or Wi-Fi, or the DSRC. Also, and it depends on the. But your primary question is regarding the V2X. So what do you want to know? This case or?
Can it be applied to the real world now? Because most of the time I found this kind of only happens in the research. So I don't know what's your point about if the CV2X can be applied to the real world.
Yes. Actually, so ちょっと待ってよ。あったっけな。あれ？ないか。Right now, sorry. So today I don't have slide, but right now, right now inside us there is a discussion for the real use cases. For example, so if we can manage lots of vehicles as a fleet of vehicles, and if the top, so if one vehicle finds something anomaly, for example, obstacles on the road, and then this vehicle can notice, so here is something dangerous one to so other vehicles behind this one. And it's also possible using the centralized manner by using cloud. But if in real world there are a bunch of vehicle fleet, and yeah, and in this sense, so managing those big, so big fleets, so depending on the place by place. So yeah, and if we and if we do so, so we can reduce the time of the notification of the so something anomalous things was so, and this is just one use case also, but so this is just an example, but still there are some more discussions so internally, and eventually so I believe we can disclose and make it public through so some place such as ACC or so. I hope my answer makes sense for you.
Yeah. Okay. Thank you.
Yeah. Oh, yeah. Okay. Thank you.